Hi, welcome to Pre-Calculus. Lecture today is about symmetry. This is one of those interesting topics that extends well beyond the scope of this course. We are going to take a look at issue of symmetry with respect to our trigonometric functions. But let's just take a look. Here's a beautiful butterfly, and you can see easily that the left and right side of this creature look just like each other. So we say this has a kind of symmetry. Here's another example of symmetry. It's a calm day in outdoors. There is a lake, and you see the picture of the mountain reflected in the lake, and you see an example of mirror symmetry. Here's another example. Is a leaf. Somehow the left and right part of this leaf are two distinct colors. It is exhibiting a kind of symmetry. Here is a different kind of symmetry. We're going to call it central symmetry or odd symmetry. I couldn't find a natural picture that will clearly show the topic, but we are going to talk about this thing later on. Issue of symmetry, you always see that when you're dealing with a mirror. If there is just one mirror, you have some interesting issues coming up. If you have two mirrors, some more interesting issues come up, that there is a third image. If you have paid attention to it, it looks very different from the image that you have of yourself. Next time you go to buy clothes or something, or if there is any place that there are two mirrors next to each other, try to take a look at that third image, and you'll be surprised how it looks different from what you're accustomed to. Here is a classroom setup for just what we mentioned. There are two mirrors here perpendicular to each other. The image on the left and the right are what you're accustomed to. Back there is a third image, and let me see if I can motivate you guys to go and investigate that image. But let's come back to our topic. We are going to deal with even and odd functions and identities for trigonometric functions. So what is at issue here? Let's first just explain what are odd and even functions. So if you have a function that resembles that butterfly we were looking at, so the y-axis is the body of the butterfly, and the picture that we are looking at looks the same on the left as it does on the right. So I'm just drawing something as best as I can. So this is graph of some function. What do we mean by symmetry with respect to y-axis? So symmetry with respect to y-axis. Well, it simply means that if you look at x on the right, and then of course minus x on the left, or vice versa, then the height of the function at both sides are the same. That is, this is as tall, this thing is as tall on the left as this one is on the right. Or in other words, if I go from this point to the mirror or to the y-axis and go equal distance to the other side, I land right back on the function. How do we express this thing? You say I was looking at f at minus x, and it turned out to be same as the f on x. The y was the same at both locations. Y here and y here are the same. This is symmetry with respect to y-axis. we are going to come across this expression so often, and I don't want to write it over and over again, so I'm going to abbreviate it to SWRT, indicating symmetry with respect to, and now we have y-axis. Now if such a thing happens, we have a name for that kind of a function, and we say f is an even function. What is the reason for this terminology? Because if I have f of x say equal to x squared, that would be the simplest function that shows this type of behavior. That parabola with its tip right at the origin is a simple shape that shows left and right being identical, and you notice this exponent is even. Anytime you have a function all of whose exponents are even, it's going to fall into this category of being an even function, and it is symmetric with respect to. So this is a situation where the function is symmetric with respect to y-axis. As opposed to what? Well, we have another kind of symmetry that's kind of more rare in nature than the other one, but it is important for us. And this is example of a function that let me draw something. Let's see if I can draw something reasonable. So a wave looking function has this type of property that if you are on the right, if you are at location x and y on the right, if you go on the left, so now you're at minus x, the height is also negative of what it was on the right. So here the height was y, here the height is minus y, so you're at the location minus x minus y. So this one has the property that f of minus x, which is now like at this point on the left, is the negative of what it was on the right, is minus f of x. In this case we say f is an odd function, and the graph, well, what kind of symmetry is this? You have two ways of handling this. You can say it is symmetric with respect to the origin, meaning if I start from this place, go to the origin and go equal distance to the other side, I land right back on the function. So because of that, we call this symmetric with respect to the origin. Why do we call it an odd function? Because if that exponent was odd, we see that behavior. Simplest example, x cubed, or x itself also, but x by itself is just too simple. X cubed has a graph that looks like this. If you have drawn this thing back in your algebra 1 and algebra 2, you might remember that this is how x cubed look like. Like if you are on the right, say at the point 2 and 8, on the left you're at the point minus 2 and minus 8. Because of this exponent being odd as opposed to this one that was even, it's called an odd function. Now this looks overly simple compared to the depth of the idea of symmetry is all over every field, in mathematics, in physics, in sciences, and of course in art. It's a central topic. Now we are going to look at this thing with respect to our trig functions. How about our trig functions? Do they fall into either of these categories? There is of course a third category as well. There is even and odd, and then there is neither. So neither, well, of course it means, well, your function is neither even nor odd. uh, that doesn't mean the function doesn't have symmetry. Perhaps its axis of symmetry is somewhere else, perhaps its point of symmetry is somewhere else, perhaps it's some other kind of a symmetry it has. So there are many types of symmetry all around us. You just search for the word symmetry in nature, and then you'll see plenty of examples of flowers and other natural phenomena that are showing symmetry. So right now we are just focusing on this simple issue: symmetric with respect to y-axis, symmetric with respect to origin, and if it is neither of these two, we just call it neither, essentially brushing all of that under the carpet. So let's go ahead and take a look at how do the problems look like here. We are given some pairs of functions, and the question is to decide if they are even, or they are odd, or they are neither. So let's go ahead, just explain the situation, and then you can answer all these kind of questions. They're all kind of very similar to each other, so we can cover all of them. So remember, we had defined our trig functions based on this unit circle. So we have this unit circle, we have of course our x-axis, and then we have some angle here, so theta, and our trig functions are based on what happens at that location on the circle. What are the coordinates on the circle? Well, what if I come the equivalent of going from x to minus x that we had in these pictures. Here we are going to go from theta to minus theta. So all that we are doing is that we are opening the angle in the other direction. So one of them you can call it counterclockwise, the other one is clockwise, and of course if you go this way, x is the same but the y is now negative. Is that right? So remember, cosine of theta was x. You notice in this picture that that is same as cosine of minus theta. They are sharing the same x coordinate. For this reason, cosine, according to explanation that we had here, even function was when the argument flips to its opposite sign, the value of the function does not change. That's what happened here. We went from theta to minus theta. We say cosine is even. How about sine? Well, sine of theta is y, but sine of minus theta is minus y. So you can conclude that sine of minus theta is minus sine of theta. For this reason, you say sine is an odd function. Sine shares certain characteristic with this x cube, while cosine shares certain characteristic with this x squared. You are going to see in calculus 2 that we can write cosine in terms of a bunch of even powers of x. Same place you are going to see sine can be written in terms of a bunch of odd exponents of x. So if you wait about a year, you are going to see that issue. But right now, all that we are going to say is that sine is odd. Well, once we have the situation for these two functions, everybody else follows suit based on how it's defined based on these two functions. So if you look at, for example, secant of theta, you remember what secant was. Secant was 1 over x. So that's the same as secant of minus theta because they both share the same x. So secant therefore becomes even excuse me, secant becomes an even function. How about cosecant? Well, cosecant of theta is 1 over y, and cosecant of minus theta is going to be, now the coordinate here is minus y, so I'll have 1 over minus y. Just as up here, cosecant becomes odd there. Well, how about tangent? Tangent of theta, you remember tangent was ratio of y to x. How about tangent of minus theta? Well, now our y coordinate is minus y, our x coordinate is the same. Therefore, let me write this thing. Cosecant of minus theta is minus cosecant of theta. Cotangent of minus, excuse me, sorry, tangent of minus theta is also minus tangent of theta. Cotangent, same way, just that you have x over y, so for that one, cotangent of minus theta is also minus cotangent of theta. So to make it abbreviated, the only things that are even is just cosine and its reciprocal, that is secant. Everybody else is odd, so that includes sine and its reciprocal, which is cosecant, as well as tangent and its reciprocal, that is cotangent. So that's a simple description, but the story goes far beyond this simple picture. So what happens here? Secant, what's the deal? So we said secant, just same as cosine, is an even function. Yeah, these two in the same category. Now, when you're answering here, it's not asking you to calculate what's the value of this thing, or you shouldn't look for a calculator or something. The question is, if I put a minus here, what would that be? Well, the answer is that if I calculate secant of pi over 5, I'll get the same thing as the secant of minus pi over 5. Same for cosine, that's same as cosine of 53 degrees. Positive or negative doesn't make any difference. Okay, now you want to have a mental picture of this and be able to recognize the situation quickly. For some reason this is already answered, I don't know why, but tangent, you remember we said tangent, cotangent, sine, cosecant, they are all odd functions, so this is same. So what does this mean? It means the minus survives the process, becomes minus tangent of 4 pi over 5. You can calculate it and then make it negative later on. Same story here, this is same as cosecant of minus cosecant of 175 degrees. Cotangent, cotangent is an odd function, sine is an odd function. This is minus cotangent of 17 degrees, and this is minus sine of pi over 11 radians. So to go back, we had the concept of odd and even functions, and then whatever is left was called neither, so there's a category of neither as well. We talked about what that means. Here's the definition. That we are going to see in this class, and in your calculus class and so on. So we extended it to the situation that we are looking at an angle and it's negative, and with respect to these six trig function, we saw that with cosine and secant, there you could kind of say the negative evaporates, like cosine of minus theta is same as cosine of theta. So let me write it one more time. Cosine of minus theta is same as cosine of theta. And similarly, secant of minus theta is same as secant of theta. Everybody else, the minus survives. So we have sine of minus theta is minus sine of theta. Cosecant of minus theta is minus cosecant of theta. Tangent of minus theta is same as minus tangent of theta. Cotangent of minus theta is minus cotangent of theta. So we have two categories of functions here. So we mentioned you are going to see this topic in your science classes in a variety of formats. Well, this is an article in Nature magazine that trying to explain where does symmetry coming from. Well, this is a Wikipedia page on the issue of symmetry. You want to take a look at that. This is also a collection of pictures of symmetry in nature. There are a lot more of these symmetries. Just quickly going over this collection of pictures. You look at, this is so-called pentagonal symmetry. Very interesting. This is a hexagonal symmetry. This is a pentagonal symmetry again, and so on. So yeah, it's not difficult to find picture of symmetric objects in nature. They're just all around us. Understanding where it comes from is a major topic in biology or other areas, or physics, and all in all, a very interesting issue to look at. So other than just learning a few formulas here and there, you want to know what is the connection to the world around us. Okay, until next time, good luck and God bless.